The following pre-recorded webinar features industry experts from Precision Roll Grinders and FP Innovations discussing ways to help you drive costs down and increase profitability through the elimination of roll barring in your calendar rolls. These experts also take an in-depth look into several recent studies that analyze paper and the opportunity for improved efficiency and cost reduction as a result of using expertly ground rolls free from barring.
We're going to talk about ways of identifying poor roll condition. Then we'll go over the case study that Frederick did and a newsprint sheet here in the U.S. Then we'll talk about proven steps to eliminate barring, chatter, and feed lines in your rolls. And then we'll open it up for questions after that. So in order to identify poor roll condition, there's basically some simple ways to take a look at it. The simplest and most easily done is just to go out and look at your calendar rolls and take a look at what you have. In this case, we are showing a roll that was on a paper machine, and they typically develop barring similar to this within just a matter of weeks. This roll has probably been on in about 4 weeks, and you could usually see light barring developing in this within 1 to 2 weeks after it was installed in the machine. The mated rolls in this stack were also similar each time. Many rolls come back into mills. And if you look on the far left-hand side of this roll, you can see that there's very little evidence of any problem with this roll. This was ground outside, sealed with oil, and sent back in and installed on the machine. But unfortunately, this customer started up the rolls very frequently, and within a matter of hours or just a few days, they would have barring start to appear. So we did a simple lead test and took a look at the roll, and you could see from the lead test that the barring was still within the roll as soon as it was ground and put back in the machine. Often people grind rolls with the bearings and housings still installed, and if they don't ever remove the bearings and housings, or do it rarely, they don't come across this little phenomenon here that we show is you actually have chatter or barring on the bearing seat, and this is quite common, and if you grind on bearings and housings all the time, this may not be very prevalent. Also, we're talking about calendar rolls primarily today, but if you have a press section roll that is always developing vibration, chatter, or potentially barring, and the housings and bearings are never removed on that, you may want to take a look at the journal every now and then and clean that up. A customer sent us a freshly ground roll about 5 years ago, and they were having problems with barring developing and vibrations developing within just a matter of days after startup. This roll, we took off the paper that was on it, and we measured it, and we found that the shape of the roll was considerably out of specification. It was supposed to be within 2/10,000, and it was at 2,000 on TIR. And if somebody is not measuring the shape of that roll in at least 3 planes, it's going to be difficult to catch this. And in this particular case, the people that were measuring this, we've been told, was they were actually measuring the TIR close to the grinder wheel. And you need to really measure that TIR, total indicated runout, 180 degrees opposite the support point. That way you can really see what is going on within your measurements. In this particular case, this customer had 2 rolls, the king and the queen roll, that had this TIR out by 2,000ths, or the roll is actually, we found to be banana-shaped, and that explained why they were getting into these problems that developed over a period of time. Upon grinding, that was resolved. So we've asked Frederick to talk about his testing on a sheet that we found with severe barring in it in the newsprint industry, and we talked about previously he'd found a Canadian mill that had up to 20% strength loss, but we wanted to see how this U.S. mill compared. So Frederick, I'll turn it over to you.
Okay, so Precision Roll Grinders sent us newsprint samples from a U.S. mill located in the south. The paper samples were marked with barring, and they wanted to identify the variability on the strength or the negative impact of barring on the strength and other properties of newsprint, such as, for example, gloss or caliper in machine direction. So we have completed some tests on the samples with barring and to look at the variability in machine direction. So we have a TAPIO tester at FP Innovation that is used to evaluate at high resolution and high accuracy the paper properties in machine direction with a resolution, for example, of 0.8 millimeter in machine direction. So every 0.8 millimeter we measure gloss, caliper, density of the paper. We have tested a strip of paper with boring with a length of 150 feet, and we have also analyzed the strength of the paper, the tensile strength, with an Enstrom instrument to look at the stretch and the tensile with a resolution of 12.5 millimeter or half an inch in machine direction. So we have tested this on 10 feet of paper because it's a long test. We have to do it on 4-inch strips, so we have to do it on a limited amount of paper. So the next graphs will show you the machine direction property. For example, the first graph shows the caliper variation along the machine direction, and you can see that caliper variations are up to 5-10 micrometer, or if you prefer, a quarter of a tau in the machine direction of the variation. So there is a lot of periodic variation. If you look at the FFT, fast Fourier transform, or frequency analysis, the bottom graph, you see that there are some periodic variations in machine direction ranging between 1.1 and 1.4 inches. So every 1.1 or 1.4 inches, there are some variation in the caliper due to boring. The next graph shows the same kind of analysis for the gloss. Here you have that the boring negatively affect the gloss with 1% amplitude. I mean 1% of the gloss. So you have ranging from 9 to 12%. But if you look at the frequency analysis, again, the 1.1 and 1.4 inches wavelength are there, and explain 1% of the gloss variation in machine direction. And the density is also affected by boring. As you can see, we have amplitude up to 2 pounds per cubic feet in machine direction that are due to boring. This will have a negative impact during reeling and probably winding, as you can have some kind of periodic variation in the density of the web or the sheet. You can create vibration at the winder. And another interesting property to be analyzed is the machine direction stretch. Here we have a variation that we clearly see in machine direction. The stretch varies from 1 to 1.4%. But let's assume you want to produce a paper newsprint at an average of 1.2% stretch. Your customer are gonna see, or the presses will see the lowest point or the weakest point of the web. Here we have values around 1, 0.9, 0.95, and this will probably cause kind of breaks, or could break on presses, because the presses is an even tension, and those weakest spots will cause kind of runnability issues on presses. So it's not only important to look at the average, but also at the weakest point on the stretch. And you can see here that the stretch is really affected by the boring. Same thing for the tensile. We found that there is a periodicity in the pattern, and as you can see in machine direction, the lowest point, the tensile, will also affect the runnability of presses. And we found a relationship between MD tensile and MD stretch. So the lower the stretch, lower the tensile. So boring really affected both properties as well as other properties of newsprint. So if you look at the MD strength, a comparison of the zones with and without boring of the newsprint, you have in red the zone with boring, and in green the zone without boring. you see that paper with barring as in that case here has 10% less strength than paper without barring. Same thing for the stretch, but in that case here we have 18% less stretch with barring compared without to the paper without barring. So in summary, we have seen that barring negatively affected the newsprint machine direction properties. Paper with barring is 7% thinner, 10% glossier, and 5% denser because the caliper is smaller. And we have also seen that barring negatively affects newsprint machine direction strength. The barring is paper with barring is 10% less stronger and also has 18% less stretch. So Bob will continue with solutions to reduce or improve sheets without barring.
Thanks, Frederick. We'll give you an opportunity to ask Frederick some questions here at the end. There are 3 proven steps to improve your sheet and thus improving your profitability. One of the simplest ones that I alluded to earlier is make sure that when you're grinding your rolls that you remove the bearings and housings prior to grinding. Also make sure that the bearing seat and the setup spot are ground round and concentric so that to the bearing seat so that you can minimize the opportunity for wiring to redevelop later on. Also, by measuring the roll shape in a minimum of 3 planes allows you to check your roll to make sure that it is as close to the roundness that your equipment's going to be able to allow you to have. And if somebody's measuring the TIR, they need to measure that TIR for you 180 degrees from the support point. Typically, you're going to need to remove at least 10 thousandths on radius from your calendar rolls to ensure the barring is removed from the roll face. Let me repeat that important part, 10 thousandths on radius, or normally 20 thousandths on diameter. And you need to grind the roll to the original specifications or tighter. Over the last probably 10 to 15 years, the paper industry in some cases went the opposite direction. And I think this caused considerable problems for some people. We typically see 2/10 on diameter for most paper machines, calendar rolls today for both shape and TIR. And we've had some customers want to go down even tighter than that. If you have any questions, and every now and then you will be able to see that at 10 thousandths on radius that you still have some severe barring in there. It'll show up on your in your grinder. The amps will be changing, or you'll still see it in the roll. You can take that down a little further till that's gone, and if you still have concerns down the road, I alluded to the equipment that Frederick have. You can bring FP Innovations in to measure your rolls, and he can tell you within 2 millionths how much barring you still have remaining. One of the keys to a good grind on a roll is to make sure that you grind in a good controlled environment. We've seen some roll grinders run with especially in the wintertime, with hot air blowing on one end of the roll and the door open to 5 degrees above zero on the opposite end, and this is going to make it difficult for a paper maker to make an even sheet. Also, you need to have your grinder on an isolated foundation. We've got a couple of mills that we're doing work with right now that actually have the grinder on the operating floor, and they happen to have some of the worst barring that we've seen in the paper industry. So there's a fairly good correlation there. Whenever a forklift goes by or somebody bounces something on the paper machine, that it transfers all the way through to the grinder. And then, of course, you've got to maintain your grinder. You've got to make sure the bed alignment and all of the upgrades are up to date, and they've got to be calibrated frequently to the specifications that you've set. All our grinders are CNC grinders that we've been doing this work on, and that allows us to get the tighter tolerance that some of you folks have asked us to do in the past. One bonus tip or two here for you. One of the things we found after we've ground somebody rolls for the first time after they've been running and somebody else has been grinding them for many years is that they should be rebalanced. Quite often after we grind them for the first time, we putting the balance weights back in the original holes. So after you had your rolls ground and the barring's removed and they're back in proper shape, there's a good chance that they need to be rebalanced. And make sure that when you install your barring-free rolls in your calendar stack that you're installing them with other rolls that are barring-free as well. Typically, if you're going to mix rolls in your stack's going to go to the condition of the worst roll, and if that's a barred roll, it's just going to transfer that barring throughout it. Obviously, as Frederick just alluded to, that when you have barring-free rolls, it maximizes your sheet strength, your finish quality, and your stretch. And this obviously is going to minimize the sheet variation and the customer runnability issues in the press room or on their equipment with whether they're making envelope or whatever they're converting that paper into. And it will maximize everybody's equipment life if there's no vibration and barring, both at your facilities and at your customers' facilities. And in order to make sure your rolls are always in specification from Precision Roll Grinders, you can check on our website for the 24-point spec check that we go through every time that we conduct work on your rolls. So some final thoughts. Obviously, Frederick's research has found that barring-free sheets are stronger. In the case of this particular mill, they lose 10% of their strength because of barring. That has got to affect the runnability of paper machines and winders, and obviously it's got to affect the converting equipment and the ultimate end user. Barring-free sheets have a more uniform surface. We have seen this in other industries, the aluminum industry. They have better converting and better printing of their sheet. It's got to have better results in the paper industry with better printing and converting as well. And we've also been told by customers that have used barring-free sheets, they run faster. So better converting and faster converting, you have a uniform sheet out there in the marketplace. And we've got some customers that have told us that when this occurs, they get more and more repeat business. Additionally, when one customer resolved his barring problem, he actually was able to move up grade into a higher quality grade, and thus a more profitable product line for him to sell to his customer base. So that was just a side benefit that he got just trying to eliminate the barring that he had in his machine.
Learn more about how Precision Roll Grinders can keep your business efficient by calling 610-395-6966 or visit precisionrollgrinders.com.